All right, let's dive right in. Today we're talking about a huge upgrade in how AI finds answers. We're looking at a leap that basically transforms it from a simple assistant into, well, a genuine researcher. This is the world of agentic RAG.
So we've all been there, right? You ask an AI a question, and it just confidently spits out something that's completely wrong. I mean, totally off the rails. Why do these incredibly powerful tools sometimes get things so catastrophically wrong? It's a really common problem, and it points to a big limitation that, thankfully, we're finally starting to solve.
You see, the old way of doing things, which is what you're looking at here, is kind of like treating the AI as a junior researcher who you have to spoon-feed everything. You just hand it a stack of documents and say, okay, you can only use these to find the answer. And if the key piece of info isn't in that stack, well, the AI is completely stuck. It's got nowhere else to go.
So that brings us to our first section, the AI's reading list. Let's dig into exactly how this whole spoon-feeding approach, which is more formally known as naive RAG, actually works.
So what is naive RAG? That name, RAG, stands for Retrieval Augmented Generation. But in simple terms, it's a system where an AI answers your question based only on a fixed set of documents it's handed, all in one single shot. And the really crucial part here is this. The AI has absolutely zero control over the research process. It can only read what it's given. That's it.
But what if we could change that? This is where it gets exciting. Welcome to Section 2, Unchaining the AI Researcher. We are about to promote our AI from just a passive reader to a truly active, autonomous investigator.
And this slide just lays it out perfectly. On the left, you've got passive RAG. The AI is stuck inside a box with a fixed reading list. But on the right, you have agentic RAG. Here, the AI is unleashed to actively go out and explore an entire web of knowledge, finding the answer for itself. I mean, this isn't just a tiny tweak. It's a total game changer for AI autonomy.
This diagram really gets to the heart of it. You see, other advanced methods, like graph RAG or workflow RAG over on the left, they're still just following a set of fixed, pre-programmed steps. But look at agentic RAG on the right. It's the only one that can come up with its own strategy, on the fly, search over and decide for itself which tools to use. It's not just following our instructions anymore, it is truly in charge of the investigation.
Okay, so if the AI is now in charge, how does it actually, think? That brings us to Section 3, where we're going to look at its brand new toolkit.
So agentic RAG, or ARAG, gives the AI 3 core tools, and they work a lot like how you or I might do research. First, it can do a keyword search. Think of this like looking in a book's index for an exact name or a specific term. Second, it's got semantic search, which is more like browsing a whole section of the library to find related ideas and concepts. And finally, there's chunk read, which is basically pulling a promising book off the shelf and reading the whole chapter.
And this diagram just maps it all out. The agent gets a question and it starts to think. It might kick things off with a keyword search to find a specific name, which points it to a little snippet of a document. Then it might use semantic search to explore some related concepts. And based on all those clues, it uses the chunk read tool to get the full text, deciding all on its own when it's gathered enough evidence to give a confident answer.
Now, this all sounds great in theory, but does it actually work better? That is the million-dollar question, right? And we're going to tackle it in Section 4, The Agent Outperforms. And the answer is a resounding yes. Just look at this data. This is from the Hotpot QA benchmark, which is a really tough test for AIs. Naive RAG, the old way, scores about 79%. Even a more advanced method, Hippo RAG, only gets to about 85%. But look at this. A simple agentic RAG just blows them away, jumping all the way to nearly 91% accuracy. That is a massive leap in performance. But wait, here is the real kicker. It's not just more accurate, it's also way more efficient. On that exact same tough dataset, the agentic RAG model used 49% fewer tokens. So, in other words, it did almost half the amount of reading
and still got a more accurate answer. I mean, just let that sink in for a second. The AI is doing almost half the work to get a significantly better result. It's the absolute definition of working smarter, not harder.
Now, what usually happens when you solve one big problem in science, you end up revealing the next one. So let's look to the future in Section 5. What's the next bottleneck?
This quote from the research paper just sums up the new reality perfectly. The bottleneck has shifted. The core problem is no longer that the AI cannot find the right information. The problem now is that it found the documents but reasoned incorrectly. We've given it a library card, now we have to teach it how to actually think critically about what it reads.
And this chart just drives that point home. When agentic RAG fails, look at why it fails. An absolutely overwhelming 82% of the errors are now reasoning chain errors. What that means is the AI is finding all the right puzzle pieces, but it's struggling to put them together in the right order. Finding the info just isn't the main problem anymore.
So what do these reasoning errors actually look like? Well, the single biggest culprit, making up 40% of them, is something called entity confusion. This is where the AI literally mixes up people, places, or things, even when the correct information is sitting right there in the text. It's like finding the right names in a history book, but getting totally confused about who did what. Other big errors are things like using the wrong search strategy to begin with, or just not understanding a complex question.
And that leaves us with this final, crucial question. Now that our AIs have finally learned to find information like a world-class researcher, how in the world do we teach them to reason like one? Because that is the next frontier.